So hi, good morning. As you said, my name is Omer, and you probably hear that I'm also not a native. I'm from Israel, like Michael. So I'm very excited. It's a big honor to be here, so thank you. Thank all the organizers for choosing me and letting me be here. Today I want to talk about authentication, and I want to ask, is there a other way we can perform authentication? Can we authenticate without authentication? Why am I asking that? Let me tell you a story. This is the story of Soluto by Shuran, the company where I am working on. Someone here heard about Soluto or Shuran? Shuran is probably more familiar. Who heard about Shuran? We have some employees, so it should be. Yeah, okay. I want to tell you our story, and to that get to the reason I want to talk about authentication, because we had an interesting issue. And before that, I want to give you some context about what is Soluto, what we are trying to do. So at Soluto, we are trying to help people get the most out of their technology. And I'm sure you too have a lot of smart devices at home, like smart cameras, smartphone, smart refrigerator, smart whatever. And we don't always know how to get the most out of all those technologies. For example, how I can connect my smart printer to my smartphone. And we at Soluto want to help people with that. We want to help them get more with the technology they already have. And we are doing that with our mobile application. This is the app. You might be familiar with it if you have it. And the app give you the app give you a lot of tips and tricks and guides that can teach you new things about the technology you own. And it also gives you an easy and convenient way to contact an expert in case you need it. Now, when we started to work on this app, it was 3 years ago, we started thinking about authentication. I'm sure you all know that authentication is important. We're at AppSec Cali, so I don't need to convince you that authentication is important. But we wanted to ask how we are going to do authentication. And you must be thinking that it's simple, right? Just add one of these, social login or regular login with username and password, and that's it. You have authentication. But things weren't that simple. And we didn't want to use that mechanism because this is a mechanism that will affect the user experience. This is something each new user will have to do as part of the onboarding flow, where the user actually starts using our app. And it could affect the user experience, and it also could affect the number of users who actually start using our app. This is a quote from Optimizely. Optimizely talking about 56% drop, which is a lot of users to lose. And they offer a few tips that you can do to make logins better and lose less users. But even if we apply those tricks and go to, 20% users, it's still losing a lot of users just because we wanted authentication. So basically, we had to choose. And we had to choose between security and usability. Because either we will choose security and we will add authentication, but we will affect the user experience, or we will choose to go with usability. We will not add authentication. We will have great user experience. We will not lose users, but the app will be not secured. And it's really, really big security flow, launching an app without any authentication. So this is the choice we had, and this is a choice we didn't want to make. We want to have both security and usability. And we decided that we need to find a new way to perform authentication, a way to authenticate the user without affecting the user experience, authentication without authentication. So we decided to go for it. And I started to work on this project. It was 3 years ago, like I said. And it was a very long project. It was around half a year. I worked with it with a few other people from the team. But it is now working, and it's live in production. And this is why I'm standing in here, sharing all our story with you. because it is working, and I don't think that we are the only one who faced this choice, who had to choose between security and usability. So I want to share with you our solution, how our solution works, because I think it could be relevant to each one of you. And it's also important to say that our solution was for mobile, but it doesn't mobile only. It could work for anything, including IoT, like smart refrigerators or smart cameras. And this is another reason I'm sharing this, because it's not a limited solution. So this is what I want to achieve. And before I start talking about all the technical details and how I did it, I want to talk a bit more about what does it even mean, authentication without authentication, what I want to achieve. If in regular authentication, I'm going to authenticate the user with some credentials. The user credentials may be MFA if this user has MFA. And then I can do authorization based on the user properties. For example, its name, the group the user belongs to, or actually any other properties this user has. If I'm going to authenticate without any user interaction, I will only be able to authenticate the device. Find some credentials that I can use, so I can know that the request comes from the device, a specific installation of our application on this device. And then the only thing I can have for authorization is this identifier. I can say that this device is allowed to this data because it's data that came from this device, or something like that. Now, something that's important to notice here is that there is no user information. Because I choose to authenticate the device and not the user, I will not have any information about the user who actually performed the operation. All I know is which device it came from. And that's something important to say, because if we're going non-interactive authentication, it means we don't need the user. And for us, that was exactly what we need. So this is what I want to achieve, a way to authenticate the device. And now let's start talk about the more interesting part, which is the technical part. So the solution is built from 3 protocols: OpenID Connect, digital signature, and one-time password. And I will now go with you through the process of building this solution, one protocol after one. And I'm going to start with OpenID. So how many of you are familiar with OpenID? Who here used OpenID? Cool, it will be a lot more faster. But I will explain it for the rest, don't worry. You will get understanding of it. So OpenID is a protocol used for authentication or authorization. And OpenID aims to give 2 things. The first thing, it gives us a way to validate the end user identity, what we call authentication. And the second thing, it gives us profile information about the user. So we can use this profile information for authorization. And of course, it has an RFC. You can check it out later. So how OpenID works? OpenID works, it's talk about 2 participants, relay party and OpenID party. The relay party is our client. It could be mobile, like iOS or Android, and it could be web, Chrome or Firefox. The OpenID provider is the server that actually performs the authentication. So it could be, if we're going to do social login, Facebook, Google, Twitter, or even Microsoft. Now, when the client wants to authenticate the user, the first thing, the client initiates authentication request to the OpenID provider. The OpenID provider is responsible to authenticate and authorize the end user. And if this step succeeds or not, anyway, it will return a response to the client. So the client can know if the authentication succeeds or not. And if it succeeds, it can use some token, some string, to authenticate requests to various APIs. So this is a very high-level overview of OpenID. And this is why I wanted to use OpenID, because it's a very, very popular protocol. You can say it's becoming the de facto standard for authentication. So it looks very promising, but we have one problem here. We have end user, and end user is the problem, is what I want to eliminate. So the question I ask myself is, can I eliminate the end user is there a way to build this OpenID flow without any user interaction? The nice thing about OpenID is that OpenID is highly modular. There are various ways to perform this authentication request, the first request. Each way called flow. And there are a few flows already defined in the RFC that you can use. But I couldn't use each one of those flows because either they required user, which I don't want, or they required storing some kind of hard-coded credentials at our mobile application code. And storing credentials at the code is not a good idea because anyone who has the app also has the credentials. So to use OpenID, we need a new authentication flow. But if I will be able to come up with a new authentication flow, it will give I could use the full OpenID protocol like I showed before without any further changes. And I can also use any OpenID stack available today, which is really good. So I started to think about what requirements do I want from such a flow. And I started to list those requirements, so let's go over them. The first and the most obvious requirement is I want it to be strong. I don't want something that is easy to break. As I said before, I also want a unique way to identify the device, so I could perform authorization. I want it to be simple, because simple means less code to write, less bugs, less security issues. I want that this authentication request, the authentication flow, will be unique per request to block replay attack, among other things. And the last requirement, I want it to be fault tolerant. As we all know, the network request will fail, and I want our client to be able to recover from such failures. So those are the requirements. And with those requirements, we also started to think about potential threats. What kind of threats probably we are going to face if I'm going to authenticate the device? Those are threats that coming from the fact that I'm going to authenticate the device. So for example, if someone stolen or compromised your device, she's probably going to be able to use anything on the device and impersonate your device because she owns it. But this is an easy threat because there are a lot of existing mitigation that the OS give us, Android or iOS. So we didn't need to handle this one. The second one is man in the middle. And this is also pretty much solved because we are using HTTPS and certificate pinning. So when using both of them, it's very hard to overcome and perform man in the middle, but still possible. Now, the last three threats are threats that I want to mitigate. The first one is temporary device access. It's different from a stolen or compromised device. This one more talking about you give someone a temporary access for your device. For example, you go to a store and there is a technician there, and this technician going to connect your device temporarily to her computer. So she's going to have temporary access to your device, and they want to make sure that even if she has temporary access to your device, she will not be able to impersonate you. The next threat is reverse engineering, which is because we are talking about mobile, threat that is always exist. And the last one, sensitive data exposure. This is more server-side threat. I want to make sure that even if someone was able to breach into our server and get all the data from it, it will not help to that someone to start impersonating devices. So those are the threats and the requirement. And now let's start see how we can fulfill them. So I want to find a new authentication flow for OpenID. And digital signature seemed like a pretty good solution for that. Why? The first reason, the animation didn't work well. There are a lot. The animation really didn't work well. Okay, I imagine it was the opposite way. I should check it up. My bad. Anyway, the first reason is that digital signature is widely spread. I'm sure you're all familiar with HTTPS and TLS. And they both TLS is heavily using digital signature, meaning that any device out there, which is basically most of the devices, not all of them, has already support and using digital signature. So I can assume that our code is running on something that can do digital signature. The second reason is that there are a lot of existing implementations like OpenSSL, and because of TLS SSL for digital signature. And this go back to the simple requirement. I will not have to write all the heavy part of digital signature myself. I can rely upon existing implementation. And of course, digital signature is a pretty strong solution. So I started to think how I can use digital signature to build an authentication flow from that. And in a very high level design, the device will have to perform one-time registration. It's like the first time the app is installed or something like that. And then after this registration completed, the device will be able to perform authentication request. So let's see how each one of those requests look like. So this is the registration request. Let's start see what's going on here. The first thing the device needs to do is it needs to generate a keeper. We are using RSA, but any other asymmetric encryption could also work. Beside of this keeper, the device also has unique identifier. It's just need to be a number that we know for sure that is unique per device. We are using GUID for that, but again, any other mechanism could also work. So now the device has this keeper and its identifier. It can send all this data to our authentication API, which is just the name of our OpenID provider. This server can store this data in a database. It could be key value store or any other database. And if the store succeeds, it will return succeed to the client. So this is the registration request. Now let's talk about the more interesting request, the authentication request. Before the device can perform an authentication request, it needs to sign something with its private key. I will discuss in a few more slides what is this something. And then the device can send the signature to the server. The server and the device ID. The server has the public key from the registration step, so it can fetch the matching public key to this device identifier from the database. And then it can validate the signature. Now, because of digital signature and the relationship between the public and the private key, if the validation succeeds, it means that the request was signed with the private key owned by the device. So the request comes from this device, and we can approve the request, know that this is the device, the authentication succeeded, and we can issue a token and send it to the device. So this is how the authentication request will work. Now let's go back to the list of requirements. We can see that it gives us a strong authentication solution, like I said, because of digital signature. It's a unique device identification because of the hard relationship between the device identifier and the public-private keeper. So because we have this strong relationship and we know that the device ID is unique per device, we have a unique device identification. And it's simple because I don't need to write all the hard part. I just can use existing implementation. So now we have two last requirements, which is unique per request and fault tolerant. I will now discuss what I'm going to send and how it fulfills those requirements. Also, if we go back to the potential threats, we can see that this threat is mitigated now, because all that is stored on the server side is the public key. So even if a hacker was able to get all the database with all the public keys from the server, it will be very hard for that attacker to go back from public key to all the matching private keys for all the devices. So this is pretty mitigated, which is good. It's also help with TLS. Why? With man in the middle, because the private key never leaves the device. So even if an attacker were able to break through all those protections, all the attacker will have is the signature itself and the public key. It will not help that attacker to impersonate the device. Which is very good. So now let's go back and talk about what I want to sign. And this thing that I want to sign, this payload that I want to sign, need to fulfill the last two requirements, unique per request and fault tolerant, and also help with those two threats. And when I started to think about what I can use to sign, one-time password seems like a good candidate. One-time password is a protocol or set of protocols that usually use to generate a unique password for each request. It's a protocol that describes how a client can generate a new password each time and how the server can validate it. And it's used in various places. For example, Google Authenticator is a very known example and uses of one-time password. And it is usually done either with time or with a sequence. And we couldn't use either of the existing implementation. So I wanted to come up with a new one-time password solution that I can use for that signature. So I want to use one-time password to generate something and then sign it with the device private key. So let's see how. Now, if I said before that the device generates the private public key and send the public key to the server, now let's say that the device also generates two numbers. I'm going to call them old and new. Each one is a signed 64-bit integer, and I can use crypto random to make sure those values are truly random. So the device can generate those two numbers and also send them to the server. So this is now the end of the registration. The device has the private key and the public key and those two numbers, and the server has the public key and those two numbers. Now let's look on authentication request. Before the device will be able to authenticate, it needs to perform rolling. What does it mean? I hope you can see old get the value of new, so now it's 2, and new get a new crypto random value, so now it's 42, just for the example. Now it's like I said before, the device will use the private key to sign this payload, and will send the signature and the device identifier to the server. The server will match the public key, validate the signature, and then will come the interesting part of validating this payload. How the server can decide that this unique password is valid. The server compare and check that new on the server side, the one stored on the server database, equal to the new come from the client. In this case, 2 equal 2. So the request is valid. The server update the payload stored on his database and return a token to the user. So this is how the device performs authentication. And I hope that now you can see that it's give us unique per request, because before each request the device will have the role. The same payload will not work. It also gives us fault tolerant, and I will show in a minute why. So it's pretty good. And if I go back to the list of threats, you can now see that I'm not storing anything hard-coded on the code, so there is no reverse engineering threat. We only left with temporary device access, which I will cover also in the next section. Any questions about this part? Something that was unclear? Yes.
Ends up in another device, how would you prevent that?
I prevent that because each device has its own unique identifier. So if you are using GUID, each one will have unique GUID, and it's pretty good assumption that they will not get the same GUID, so they will not end up in the same device identifier. He was asking how I can prevent one device overriding other device public key, correct?
Well, it's just if the private key is not stored properly, somebody could take it out and put it in all devices and basically just use the same private key.
So you're asking what will happen if someone will read the private key from the device. So it's related to this and this threat, and this I will discuss soon. I assume that if someone stole or compromise your device, for example, install malware on your device that allow him to access to anything on the device, I hope that the OS is able to protect from that, and if not, it's something for us as a software company will be pretty hard to protect. We will use just the best mitigation the OS give us, and there are various. We can keep the discussion later. But again, this I will discuss soon.
I have one more, if that's okay.
Yeah, I think we said.
The scheme that you just showed, it seemed like the new code is going from the device each time to the server, and then server keeps it and expecting next time. Is that the scheme?
Yeah, the device is responsible for generation of the keeper and those two numbers.
Okay, thank you.
Okay, good. I think I have one more question. If someone has another one, yes.
Did I understand it correctly if you said you're using the public key to present a challenge to ensure the integrity of the key in the middle of this negotiation? Or was
no, there is no challenge here. The device sends the signature and the server validates it on the server side. It does not, that's the challenge, but not in the know how it's used in various authentication protocols.
Okay, got it.
Okay, so let's move to the next part. And as I said, I want to cover now two things that I left, fault tolerance and how I handled temporary device access. So let's start with fault tolerance. As we all know, and I'm sure that anyone who ever write code know this, network request will fail, it's guarantee. And it could happen for various reasons. For example, timeout, just temporary network failure, or even server-side errors. Now, when such an error occurred, the device needs to be able to recover from it. And basically, the device needs to differentiate between two states. Either the request did not get to the server, and then the state on the server side did not change, or the request got to the server already updated the state, those two numbers, but for some reason, the client did not get a response. So I'll now go over on each one of those states, and I show how the device can differentiate between them and how it can handle them. And let's start with the first case, where the server state did not change. It's the simple one. So the device sent this payload. I omitted all the private publicly for simplicity, but it's the same as before. The request did not get to the server for some reason. The device received an error. In this case, all the device needs to do is retry, and after the next retry, I hope that you can see that old equal new, so the device will get a token. So this was the simple case. Let's talk about the more complex one, where the server state did change. So in this case, the device sent those two numbers. The server compare old and new. Old and new are equal. So the server state changed on the database, but for some reason, the device did not get the token. It got an error. In this case, if the device will retry, you can see that the request is not valid, right? Because old does not equal old. So the device will not get a token, but the server recognizes this is a special case. You can see that the payload is totally equal, old equal old, new equal new. So the server will return bad request 400 to the client. The client is expecting to receive this 400, and in this case, the client will just roll the payload. And now, after rolling, the request is valid, 4242. So the server state will update, and the client will get a token. And this is how our protocol is fault tolerant. Now let's talk about the second part, which is how we are mitigating temporary access threat. And to explain that, I want to present Eve. Eve, she is the best hacker in the world, and like in any good movie, to hack into anything, all she needs is just put her hoodie on, open the terminal with green characters, and that's it. She's in. So let's say we have Eve, and Eve, as she's so amazing, got temporary access to one of our devices. And now Eve has the private key and those two numbers. Now what Eve can do? Of course, Eve can request a token. She has the private key and the payload, so the request is valid, and she got a token. She was able to impersonate one of our devices. What will happen the next time the device will request a token? So the next time the device will request a token, the request is not valid, right? Because old does not equal new. But it's the same as the error case I discussed before. The client will get 400, supposed to get 400. Something bad happened here. Sorry. Wait, I'm sorry for that. It worked on my device. Anyway, sorry for all that. Okay, there was supposed to be here one case where the device is out of sync, the device roll, and now after rolling, the device will get a valid token. Okay, so after the device recovered from the bad request, you can see that the device state and Eve state is totally different because they go out of sync. And the next time Eve will request a token, Eve request will not be valid. So it looks like a bit more like the error case I showed before because old equaled old, but the new does not equal new. In this case, the server responds with panic. What does it mean? First, the server revoke the device public key from the database, so neither Eve or the device will be able to request more token. Also, in order not to expose information, to disclose information, it will return only bad requests to Eve. So Eve will not know we'll get her. And of course, the server can also trigger an alert. So someone could go and check out what happened. And this is how we mitigate temporary device access. Any questions about one of those? So you're saying Eve is smarter and just disabling the device. I could argue that it's pretty much the same like temporary device access, like full device compromised somehow. And this is a case we are not handling. Let's take it offline and see how we can see it. Yeah, I want to take more questions of understanding. Other questions, let's take under. So if it's... So you're asking if Eve did two requests? So yes, the device will get... I don't mind which one of them will trigger it, but occasionally one of them will trigger in it and lock out both of them. Which is a good question because I forgot to mention that in order for this solution to work, we need to make sure that each device will try to authenticate at least once a day. If I cannot guarantee that all devices are trying to authenticate at least once a day, this will not work. So thank you for reminding this. I will continue now because I don't have a lot of time. We can do questions later. Okay, so now to the interesting part. This was nice talking, but let's do demo. And for the demo, let's assume that I want to build the most awesome IoT project in the world. It's really awesome. It's showing device nickname. And because it's a nickname is highly sensitive. We don't want that someone will show what the nickname of your device. And we want to make sure that only the device will be able to request its nickname. This is how it's supposed to look like, but like any good project, it's MVP, first version, so it will look like more this. And in a high-level overview, the device will do the authentication request, like I showed before, and then it will get a token, this string, and it can use this token to request the nickname of this device, and the server, the sensitive API which is storing the nickname, could perform authorization and make sure that it's indeed a device and not someone else impersonating this device. And if it's the device, it will get a name. How the authorization work? So this is how the token look like. Someone know what it is? Recognizing? What? Yeah, JWT token, correct. So JWT, JSON Web Token, to those of you who are not familiar, it's a way to describe a signed JSON token. We can verify it and decode it. So this is how the decoded version look like, nice JSON. And we have here the subject. The subject is simply the device identifier. So the server has now the device ID signed by the authorization server. So it can know for sure that this request comes from this device and perform authorization based on this subject. So this is how we can do authorization. Now let's talk a bit about the technology of the demo. So I said we have 3 participants. We have the device, the OpenID provider, our authentication API, and the sensitive API. The device is written in Ruby because it was the easiest for me. I know most of people don't like Ruby, but I like it. And it's running on Raspberry Pi. If you never saw Raspberry Pi is this small computer. So Raspberry Pi is here just to simulate IoT device. The sensitive API is written in .NET Core, again, simplicity. And the last one, which is the most important, is the OpenID provider. It's also in .NET Core because I use the library called Identity Server. Someone here using Identity Server? Nice. So yes, so Identity Server is a full OpenID implementation written in .NET Core, and it's certified. It's really, really awesome, highly pluggable, highly extensible, and it gives me the availability to develop all our small authentication flow, and that's it. I didn't write any code related to the OpenID spec, which is really good because I will probably do it bad. So let's see it all in action. All the code is available in GitHub. The links are on my Twitter account, so you can check it out later and see that it's actually working. So let's see it in action. This is an example. I hope you can see. Now, I don't know if you noticed, but there was a slight delay between the generation and starting of the request. Basically, what's going here that the device generates the keeper. Here it's going again. You can see that it takes some time. This is the device identifier. The device requests a token. It got a token, and now it can get the device name, like I showed before. Now let's test authorization. I said that I have authorization, but who trusts developers, right? No one trusts developers. So let's test and see that I'm not bluffing. And for testing, I'm going to use Zap, OWASP Zap, which is a really good tool. And basically what I'm going to do, is I'm going to rerun the request, and I'm going to change the device identifier and try to request a name for another device. And you can see that I got 401 unauthorized. So the authorization is working. Any questions about the demo? Okay, nice. So I want to acknowledge all the team at Tel Aviv and all the following people here for all the help in building this solution. So thank you. And now I hope that you saw that there is another way to perform authentication and that you ask yourself, how can you use it? So if you want to use it, come and talk with me or tweet to me or in other way, because we do thinking releasing some of it to open source. This is a project we are working on, but it will take some time. So feel free to come and talk with me, and we'll see how I can help you. And now I have 2 last requests. The first, if you get some value from this session, I highly appreciate your feedback. It will help me become better, either personally or Sketch or in another method. And this is also very important. If you can think about any security vulnerability in this flow, please responsible disclosure. I do want to hear such feedback. This is part of the reason we are presenting it, but do it responsibly. I can give you the details later or just come talk with me. And if I now go back, I started this session with this question. What will you choose, security or usability? And I hope that now you see that you don't need to choose. You can have both. Thank you very much. I was Omer, and this is our Twitter account of Soluto, so check it out on Twitter. Thank you.
Okay. Any questions or?
Yeah, I think it's better to take it offline, so just come talk with me.
Okay. Well, you got about 10 minutes, so.
Okay. Yeah, but
All right.
the rest of the crowd, so.
I have a question about the JWT token that you're generating. Are you using like some sort of the original like private key to actually sign that token?
No, the JWT is signed by a private key managed and owned by the authorization server.
Which was the service that you mentioned, right? The identity server or whatever. That's what's actually doing the signing of your JWT.
So the OpenID provider is the one responsible for generating the JWT, signing it, manage the private key, and it's all done by identity server.
Okay,
We're
got it.
using HSM to store the private key securely and all the relevant stuff. The device private key never leaves the device, so I cannot use it to sign the JWT.
Got it. Okay, cool. So I just want to make sure.
Pretty much on that same line of you have a private key on the device and a public key on the server. Why not encrypt the token in transit so if your TLS fails, your token is still protected?
We can do that. Wait, this token, you're asking why not to encrypt the token. Well, the token is not used by the device. The token is what the device used to authenticate it to our APIs. For example, if the device want to talk with sensitive API, here it is, here's the pointer. So if the device want to talk with sensitive API, it need in this request to pass this token. Using an authorization bearer scheme, I'm not sure if you're familiar with it. And the sensitive API need to be able to validate and decode this token, and it does it, OpenID is how it works.
Cool, I get it, good job.
Yeah, thanks. Yes. Okay.
Question about OpenID. So Errol, what part of OpenID you're leveraging? Is it OpenID Connect or some part of kind of a combination of OAuth 2, OpenID?
So no, this protocol is full OpenID Connect compliance. This request, this is an OpenID request. You can check out the code on GitHub. You would see that I'm accessing the token endpoint. All the validation here is done using the discovery endpoint. It's the only part that is not pure OpenID is this authentication request, which is just a different flow. So you will see all the relevant scope and all the others, but it will not be the flow from the RFC.
Because I noticed the token is not compliant.
I'm pretty sure it is, but we can check it out later. Maybe I missed something. So come to me later and we can check it out because maybe I missed something. I would love to learn.
So no refresh token, right?
You don't need refresh token here because you don't have users. So we think about it, but then we figure out we don't need refresh tokens because, yeah. You had a question?
So I don't know exactly what your app or whatever is, but let's suppose that you have a user that has a smartphone and a smart TV or a computer or something like that. So your authentication is only by device, so there's no way to like link the user across devices.
Yeah, like I said when I started, you don't have any information about the user, but we could work on a feature that's saying the user say this device, this device is mine, and on the back end I'm connecting all of those device identifiers together. But except for that, we don't have to do that, and this is what you lose when you don't do user authentication. So there is always a trade-off. You always will lose something. But we didn't need so far this user information. Hey, you have someone?
How do you manage your user session if you don't even use it?
Your user what? So there is no really session here because it's OpenID. The only thing that is familiar to session is the length of the JWT for how long it's valid. So it's not the same, but it's similar. So if you're not familiar with it, let's talk later. Can explain to you more deeply. You finished?
Hopefully last one. How do you deal with certificate expiration? Do you need to
What?
re-register?
Of the device?
Yes.
Currently, we don't expire the device publicly. It's not certificate, it's public. It's not signed by any authority or something like that. We were thinking about rolling the device publicly once in a while, but we didn't do it because it will introduce an endpoint that allow you to re-register device, and you need to choose between this risk of never expired publicly versus an endpoint that allow you to override them. So again, there is no perfect choice.
So just a little bit more detail on the token. Is this good for one request? Is it good for, like you said, if you authenticate once a day, is that for one day or?
So it's pretty much depend on the token. This is what I said about the session management.
Oh yeah.
Because I'm using identity server, I can control for how long the token is valid. So I can say that I defined highly sensitive resources, and for those resources, the token will be valid for an hour. And I have less sensitive resources that the token is valid for a day. I can do what I want and model it according to sensitivity or usability. So again, it's a trade-off between the longer the token is, the usability is bigger because you don't need to re-authenticate, which is another network request, but it's less secure because someone could, dump the RAM or anything else and get the token.
Okay, that looks it. Thanks, Omer.
Thank you.
Appreciate it.